card math is still up there, but that's everything from last year. So if you're looking to see like extra ones, you can certainly go on that to see what I did last year on stuff. But Hugo Math is everything this year. Okay. All right, so let's take a look at number 46. All right, so number 46 said the U.S. Mint began issuing quarters in 1999. There was one state quarter for each 50 states. You're collecting the state quarters and want to design a rectangular display with the number of quarters in each, same number of quarters in each row. All right, so I have 50 quarters. All right, we want to arrange in rows and columns. All right, we want the same number of quarters in each row. All right, so this number 46 is like the one that we did with the yearbook pictures. All right, so let's take a look at what that means. All right, well, for us to do this, we need to find our factors of 50. So I have rows and the number of quarters in a row. All right, so Cullen, give me factors, the factor pairs of 50.
2 and 25, 5 and 10.
Okay. So I have 2 rows with 25 quarters in a row. I have 5 rows with 10 quarters in a row. What other ones could I do, you guys? Sophia? Okay. Keep going, Sophia. So I could do 1 with 50, and I could do 50 with 1. What else could I do? Danny? 10 with 5 in a row. So these are all my possibilities. All right, so the question was, how many ways can you arrange this? So there are 6 ways. And these are all 6 ways. Yes? So it didn't, so I have written out all the ways right here. If they said, what are the ways, how many of them are there, and what are they, then you would need to write out what they are, but they just said how many. So this is us organizing and then us answering it. Does that make sense? Yeah. Ada, what can I do for you? You want to look at 29 and why 51 is not prime? Because it's divisible by some other number than 51 in itself. All right, so if I take a look at 51, this is when we use our divisibility rules. It's really important that we use our divisibility rules, and you guys got to remember those. You guys did those last year. So it's not even, so it's not divisible by 2. It doesn't end in a 0, so it's not divisible by 0 or 10. So whatever factors do I also need to take a look at? And what's the divisibility rule, Nico? 3. What's the rule for 3? Yeah, absolutely. So this is 6. 6 is divisible by 3, so 51 is divisible by 3. So that's a composite. Yes?
Why isn't 121?
What's 11 times 11? So don't just assume that it's an odd number. It ends in a 1 or a 3. Don't assume that those are prime. All right, you've got to think of your factors. You've got to think of your multiplication tables. I would just start dividing those by numbers and see. All right, but you have to know your divisibility rules. You have to know your multiplication tables. All right. What other questions do you guys have? All right, at the very end of your homework, I want you to write extra examples, and we're going to do a couple extra examples before we move on. You can either do these in pen or pencil. It does not matter to me. All right, I want you to factor 40m squared times n. So I want you to factor 40m squared times n. When you're done, check with someone sitting by you. See if you guys got the same answer. All right, who wants to do this for us? Valentina. Excellent. Okay. All right, so I have 40m squared n equals, so list out the prime factor, sweetie. Excellent. If I wrote that with exponents, what would that be? Excellent. Be able to write both. Make sure you're showing multiplication in between there, not commas. All right, I have one more that I want you guys to do, and then we're going to move on to the next section. I want you to do number 56 here. So please do number 56. So these should all be set up basically the same way. Somebody do this for me. Ada, go ahead. How many of you guys agree with that? So what are how many possible arrangements do I have then, Ada? Yep, we have 4 possible displays. You guys cool with those? Okay, get your notes out, please. We are going to jump into greatest common factor. Okay. I'm going to add some of this, some homework to us. So get your assignment notebooks out real quick. All right, so I want you guys to add to that 37 through 39. So add to that 37 through 39. All right, so we're going to talk about greatest common factor. All right, so if we talk about greatest common factor, we are in 4.2. Greatest common factor. All right, so what this means is that we are comparing two or more monomials. All right, and GCF is the abbreviation for that. So GCF is exactly what it sounds like. It is the biggest factor the monomials have in common. All right, there are two methods possible. We are only using one of them. So there are two methods to find GCF. One of them is listing all the factors of the monomials. All right, for example, if I wanted to find the GCF of 26 and 36, all right, I could say 26, that's going to be 1 and 26, 2 and, let's do this 24, that's going to make more sense to me. That might be easier. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So I'm just listing the factors. And if I did 36, it would be 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So it takes a little time. For smaller numbers, you could do it, right? It just takes a little bit more time. And if we take a look at here, we're looking at the biggest factor. If we look here, the biggest factor is going to be a 12. So our GCF would be 12. Now the problem with this is time consuming. For big numbers. Alright, so what we're going to be focusing on, and this is what you must do, that's its requirement, is prime factorization. So this is a requirement. So we're going to use prime factorization. All right, so this is our required method. So let's take a look at what we're going to do. I'm going to start right away with numbers with variables in them. All right, so I want to find the GCF of 18 xy squared and 28 x squared y squared. All right, so the first thing we're going to do is we're going to do the prime factorization of 18 and 28. So here's 18, here's 28. Somebody do the prime factorization of 18 for me. Cameron? 2, and that's prime. 9, okay. 3 and 3. Danny, do 28 for me. Okay. So this is the first thing you're going to do. Second thing you're going to do, so this is my first step. My second step is you're going to list the prime factors. So this goes back to me wanting to make sure that you're not writing them with exponents on them. All right, so I have 18 xy squared is going to be equal to 2 times 3 times 3 times x times y times y. 28 x squared y squared. Don't forget we want to know that whole number, that whole monomial. That's going to be equal to 2 times 2 times 7 times x times y times y. Questions so far? And I want you stacking them like this. AJ, sit up. I want you, you're taking notes sitting up. I want you stacking them like this. So now the third thing, our GCF, these are all the factors they both have in common. All right, and I want you guys circling them. So I'm going to go through here. They have a 2 in common. So my GCF is going to be 2 times. Well, they don't have any other number in common, so they have 1, 2 in common. They have an x in common. They have a y in common. And they have another y in common. So my GCF for this one is going to be 2 times x times y squared. All right, let me give you guys another one. Let's do, find the GCF of 48 WZ to the third and 96 W squared YZ. All of you do this, please. Come on. As you're working, someone do 48 for me. Do my prime factorization of 48. Patrick? Okay. Okay. How about this 4? Okay. AJ, do 96 for me. Okay. Pardon me? Okay. You need to talk louder, sweetie, so we can actually hear you. What about 8? Excellent. Okay. So now off to the side here, I'm going to write 48 WZ cubed is equal to 2 times 2, there's 4 of them, times 3 times W times Z times Z times Z. All right, 96, and if you do these in order of least to greatest, it makes life a lot easier. So 96 is going to be 2, so I have 1, 2, 3, 4, 5 2's, a 3, and then a W, a Y, and a Z. Questions so far? So now I'm going to circle what they have in common. So my GCF, well, they have a 2 in common. There's my first 2. They have another 2 in common. That's my second one. They have another 2 in common. There's my third one. They have another 2 in common. That's my fourth one. They have a 3 in common. There's my third one. All right, when it comes to my variables, they both have a W. They both have a Z. Those are the only ones they have in common. Now we're going to multiply that out. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 16 times 3 times WZ. 16 times 3, well 6 times 3 is 18, carry the 1, that's 48, times W times Z. There is my greatest common factor. Questions on this? All right, there's one last thing I want to talk to you about. It's something called relatively prime. All right, raise your hand if you need to see what's up there. Just tell them to come in. Hi, how are you? Good. I'm good.
I'm Denise Jarvis. I'm in Oakland County. I'm
Excellent.
doing vision screening.
Okay.
I'm trying to figure out what works best for
Okay.
for all the 7th graders. I know you all.
They're all over the place, yeah.
Thursday.
You can come any day. It doesn't matter.
Okay. What
It's just a
time is
matter
that?
of finding, well, whatever works for you, because they're mixed up no matter where they are. They're never really in their homerooms. In the afternoon, they actually are with their homeroom. So if you have a listing of homeroom students, maybe the afternoon, like after lunch. They have lunch at 11:30 to 12:10. And then after that, they are in their homeroom groupings. So if you have listings in homerooms, you can go to a class and get those students from that homeroom rather than mix up like we are here. So that's probably the best time.
So 12:15ish?
Yeah, I'd say, aren't you guys with your homeroom starting after lunch? Yes, right? You don't have another YZ? Just on Wednesday. We're talking Thursday. So Thursday after 12:15 would be great, and then we can figure out what homeroom and what class they're in.
Okay. I'll
Thank
put
you.
in there.
Thank you so much. Thank you, you too. All right, you guys, let's talk about relatively prime. So relatively prime, what that means is that 2 or more numbers have a GCF of 1. They don't have any factors in common. The only factor in common is 1. All right, so let's talk about which ones that might be. So I want you to find the GCF of 24 and 45. And I want you to compare that to, I want you to find the GCF of 35 and 54. So I want you guys to do both sets of these. So you're finding the GCF of 24 and 45, and then I want you to find the GCF of 35 and 54. And tell me, are either one of those considered relatively prime, those sets of numbers? Please stop tapping. So are either one of those sets of numbers considered relatively prime, and why? What do you guys think? Matthew? What's the GCF of the first one? It's just 3. Absolutely. All right, so if I took a look at that, there's my prime factorization and my GCF work for that first one. Matthew, why are the other 2 considered relatively prime? Yeah, we have no factors in common. So 35 and 54 are relatively prime. That does not mean that they are prime numbers. It means when you are comparing them together to figure out a GCF, they are considered relatively prime. Their GCF is a 1. Yes. Are you sure? Okay. All right, you guys can go. We're running late, so all of you can go. Yeah.